I needed to mention a few different things to you all before we left 9-1, number 31, and moved on to the next problem. First of all, let's look at what we constructed here. I know it's a little bit complicated, so bear with me. These first few numbers are the information that's given in the problem. This is the confidence level, which is the middle portion. And then what you need to do is figure out alpha, which is the two outer tails. So if the middle is 90%, then the outer tails is 10%. Then you cut that in half for the left tail, and then you take the complement of that for, it's the left tail, but it's the left tail of the right z-score. In other words, these two have to add up to 1 because they're complements of each other. Now notice, this guy's called the critical value. So in some questions in my math lab and elsewhere, you're asked to find the critical value. And I'll have students say to me, but they didn't give me x bar or sigma. Well, they don't need to. The only thing you needed to construct this critical value was this confidence level. That's it. Because from the confidence level comes the alpha over 2, and all of that stuff. So to find the critical value, you actually only need a confidence level. To find a confidence interval, which are these numbers down here, that's what you need all this other stuff for. Okay. Now, another thing I wanted to say, I'm not going to answer part B because it's really more of an essay thinking question, other than to say that never forget, what you're doing here. When you're creating a confidence interval, what you're doing is you're saying, look, if I make samples like this time after time after time after time, then 90% of those intervals that I would construct from each of those samples would contain the real mu, the real blood alcohol concentration for all drivers involved in fatal accidents. The deal is that we don't have that information, or we don't have it readily available. So we don't know what the average is. What you're doing is constructing an interval to try to get a handle on where you think the average might be for all people, or all drunk drivers, or all drivers involved in fatal accidents in this particular instance. So that might give you a clue for B. You don't know where mu is. You never know where it is. That's the point. You're just trying to take a guess at where you think it might be based on data. Last but not least, I wanted to talk about the way that we did this. First of all, by no means is this the only way to do it. Even in Excel, there's other ways to do it. DDXL will actually not do this type of problem. DDXL only constructs confidence intervals if you have a table of data. But that doesn't mean that this is your only alternative. There is also the StatCrunch, so let me show you that real quick. In here, if you go to Tools for Success, this is where I'm at, you can click on StatCrunch right here, and that'll open up this link, and then you say to run it. And then you go to Stat, go to Z statistics. Now we're picking Z again because this was for the standard normal curve. We get to use that because we know sigma. That is the reason. Sigma is known for this problem. Data means you have a column of data, which we don't have in this case, but we do have summary data, i.e. the summary statistics, the X bar and the sigma. So I'm going to choose that one with summary. So then it wants to know the sample mean, which was 0.16. It wants to know the standard deviation, which was 0.08. The sample size, which is 1200. Click Next. Now it wants to know what you want to do. Do you want to do a hypothesis test, which is chapter 10, or a confidence interval, which is chapter 9? That's what we want, a confidence interval. And we want to type in the confidence level, which was 0.90 for this problem. Calculate. And there it is. You can, oopsie, hold on, cancel. I didn't mean that. I meant to copy. And then I could go back here, right click and paste. And there it is. Right? Same information, same answers, so that's a good way to check yourself. It's a little bit faster than the long-handed way. The deal with this long-handed way is it finds other stuff for you, which is also nice. Sometimes you're asked for some of these numbers along the way, like alpha or critical value or whatever. Alright, so there you go. That's part A all done, and part B I'm not going to go over, but I gave you some hints. And next time I see you, we'll work on number 45, I believe.